I welcome us back again to our class on Physics 101, our revision section. We will call this one part 3 because we are going to be dealing on 2022-2023. Let's quickly start. Question 1 says the dimension of the following derived quantities are correct. First of all, we saw surface tension. Now, first of all, we need to know what dimension analysis is. I will first of all start by defining dimension analysis. Dimension of a physical quantity is the relationship between the physical quantity and the basic physical quantity. What do we mean by this? Remember, we have fundamental quantity as length. Listen, can must take the ultimate element. These are the 7 fundamental quantities, which we have length, luminous intensity, mass, time, temperature, amount, and electric current. So among these are fundamental. We have length, basic fundamental, we have length, we have mass, and we have time. These are basic fundamental. Length is measured in meter, mass is measured in kilogram, and the time is measured in seconds. Now, remember that I said in the other video that every other physical quantities, if they are being defined based on these 3 fundamental basic quantities, what you are doing there is dimension analysis. Okay, and that is the what I'm trying to define here. So dimension for length is capital L. Dimension for mass is capital M. And dimension for time is capital T. I know we are not novice to this. Okay, so we say dimension of a physical quantity is a relationship between the physical quantity and the basic physical quantities. I wish us to know that dimension analysis is mostly based on or gotten from the SI unit of a physical quantity. Dimension is mostly gained or gotten from the SI unit of a physical quantity. What am I trying to say here? If you don't know the SI unit of a given physical quantity, you may not be able to give out its dimension. Okay, let's try some examples. Like we have density. Density is mass over volume. Dimension for mass is M. Dimension for volume. Remember that the unit of volume, okay, let's take unit of mass is kilogram. The unit of volume is meter cube. Meter cube. So, for me to dimension this now, mass is dimensioned as M, capital M. Volume, its unit is meter cube. Meter belongs to length. So it's going to be dimensioned according to that, L cube. This becomes the dimension for density. Or this can be written as M L minus 3. This is the dimension for density. Let me take another one, speed. You remember unit of speed is meter per seconds. Dimension for meter. Meter came from L. So dimension for meter is L. Then dimension for seconds. Seconds came from time. Its dimension will be T. This is dimension for speed. Or it can be written as LT minus 1. Okay. If you observe what we have done, you see that dimension for any physical quantity is solely based on its unit of measurement. So if we don't really know the unit of measurement of any dimension of any physical quantity, we may not be able to get its dimension. Let's look at force. Remember that force is MA, mass times acceleration. Dimension for mass is already known as capital M. While dimension for A is meter per second square. Meter L, second T square. So we have times L over T square, which can also be M times LT minus 2. And this gives me M LT minus 2. This becomes dimension for force. Okay, so I believe with these three examples, I've been able to convince us that dimension analysis of any physical quantity is solely based on its unit of measurement, or you call it its SI unit. So let's look at what we are going to still look at what the question asks us to do, but I want to say some things about dimension analysis. Another thing I want to tell us about dimension analysis is that some applications of dimension analysis, some of the applications of dimension analysis, according to our book, are: one, dimension analysis is used to find the speed of an ocean wave. You can write down that. It is used to find the speed of an ocean wave, one. It is used to find the thermal conductivity of an ideal gas. These are its application. Used to find the speed of an ocean wave. Used to find the thermal conductivity of ideal gas. Number three, it is used to obtain the rate of electromagnetic energy. Three applications: used to find the speed of an ocean wave, used to find thermal conductivity of an ideal gas, and it is used to obtain the rate of electromagnetic energy. Another one is significance of dimension analysis. What are the significance of dimension analysis? You'll be asked that in the exam. One, it helps to know the unit of a particular quantity. Yes, if you know dimension of a physical quantity, you can help to call the unit. If you tell me that the dimension of a physical quantity is given as let me just say example now. Someone tell me that I have that this is dimension for a certain physical quantity. I can know it because I know the dimension. So L means meter, T means time, and I should know that this is speed, or you can call it velocity. Okay, so another significant, it is used to obtain relationship between physical quantities. Yes, dimension is used to obtain relationship between physical quantities. I will show that, I will demonstrate that in an example at the course of this class. But let's look at the limitations of dimension analysis. Number one, it cannot be used to obtain values for numerical constants. Yes, there is no dimension for constants like 2. There's no dimension for 2. Pi, there's no dimension for pi. 5, there's no dimension for 5. So there is no dimension for constants or numerical constants. Number two, it cannot be used to obtain relationship between dimensionless constants. Now, we know that there are some physical quantities that are dimensionless. That is, they have their ratio of two similar units. Example, tensile strain. We have seen that before. Tensile strain. It is elongation over length. Elongation is measured in meter. Length is measured in meter. Hence, it has no SI unit. And once a physical quantity has no SI unit, it will not have any dimension. Hope you know that. So, dimension analysis cannot be used to express a value for dimensionless quantity like tensile strain. It cannot be used to find the expression for constants like numerical constants. Okay. So let's see one or two examples that I have to show us before we go back to our work. We have seen some few physical quantities and their dimension. Okay. I want us to note some things. Note. Number one, when two physical quantities have the same units or are equal, they will have the same dimension. Note that. When two physical quantities has the same unit or they are equal, they will have the same dimension. Let's take an example. Velocity. Each unit of measurement is meter per second. Speed. Each unit of measurement is meter per second, so they will have the same dimension. So it boils down that when two physical quantities have the same unit of measurement, remember that their dimension analysis is based on their unit of measurement. So if they have the same unit of measurement, they will have the same dimension. Another point I made there was that when two physical quantities are equal to each other, they will have the same dimension. Let's take an example. Impulse is equals to momentum. Impulse is equals to momentum. Since impulse and momentum are equal, they will have the same dimension. Let's see that. Let's see dimension for impulse. Remember that this is force times time. Dimension for force is mLt minus 2 times time, which is what? T. And this will give me mLt minus 2 plus 1 minus 1. So dimension for impulse is mLt minus 1. What else? Dimension for momentum, mdv. So m is mass, which is capital M. V is velocity, which is lt minus 1. So this is dimension for impulse, and this is dimension for momentum. They are the same. Why? Because they are equal. When two physical quantities are equal, they will have the same dimension. When they have the same unit of measurement, they have the same dimension. So it is very clear now that when two physical quantities are equal or they have the same unit of measurement, they must have the same dimension. Number two, when two physical quantities are added together or subtracted from each other, they will definitely have the same dimension. I repeat, when two physical quantities are added together or they are subtracted from each other, they will definitely have the same dimension. Let me buttress this with a simple example. Imagine that they gave us something like this: P plus A over V plus V minus B equals to RT. This is a van der Waals equation of gas. Now, if they ask me to find dimension for A and B, if I'm asked to find dimension for quantity A and B, now what's something? This is, excuse me, this is pressure. A, I don't know. This is volume. This is volume. This is a quantity which we don't know. This is gas constant and this is temperature. Now, if I'm asked to find dimension for A and B, I will come here. Remember that A over B was added to P. Hence, dimension for A over B must be same dimension for P. If P is pressure, then if you have dimension of A and you divide it by V, it will have the same dimension as pressure. So what am I going to do there? I will say P plus A over V. That means P is pressure. And you know that pressure is force over area. Force is mLT minus 2 over area is m squared. There is 2m down, there is 1m up. What do? I cancel here and cancel here. Hence, I'm going to be having m raised by minus 1, L, T raised by minus 2. This becomes dimension for pressure. Remember, pressure is force over area. MLT minus 2 is force, while area is m squared. This cancels this. I have this as dimension for what? Pressure. Therefore, dimension for A over V will be equal to dimension of pressure, which is m raised to power minus 1 L T minus 2. Remember that this one is volume, so I know it. So A becomes, first of all, there is something I want us to know first. If I want to get dimension for A over B, remember that dimension for A over V will be equal to dimension of pressure. Let me put it like this. So I will make A solid of the formula so that A becomes V, dimension of volume times dimension of pressure. So that I will now be saying that what is dimension for volume? Volume is L cubed. Remember? Then pressure is m raised to power minus 1 L T raised to power minus 2. So if I multiply these two now, what I'm going to be having is, let me start with L. 3 plus 1, 4. Then m raised to power minus 1. Then we have T raised to power minus 2. This becomes dimension for A. Now, we have gotten dimension for A. We have dimension for V, which is already known, and that of D. If you divide dimension of A by V, you will see it's going to give us pressure. Let's see. This is L raised to power 4, m raised to power minus 1, T raised to power minus 2, divided by m raised to power 3. Do you understand? So this can also be written as times m raised to power minus 3. Minus 1 minus 3. Okay. We have m raised to power 3 down. Okay, let's put it this way. L over m raised to power minus 1, m raised to power, because this is m raised to power, L raised to power 3. Okay, I think I'm getting some persons confused. Let's go like this. Dimension for A is L raised to power 4 times over Okay, let me put everything up. M raised power minus 1. I'm just trying to find a way not to drive the point home, Sha. That's what I'm then. Volume is L cube. Okay. Now there is 4L up, there is 1L down. The whole of this we cancel this. So I'm having L M raised power minus 1, T raised power minus 2. And this is dimension for what? Pressure. So you see, what we are trying to say is when two physical quantities are added together or they are subtracted from themselves, they're going to have the same dimension. Look at this. They say this is volume and it was subtracted from B. Hence, then if V is volume, which is L raised power 3, then dimension for B will also be L raised power 3 because of the law that says if two physical quantities are added together or they are subtracted from each other, they will have the same dimension. I believe that is very, very clear. Also, remember that we said that dimension analysis is used to find relationship between two or more physical quantities. Let me give one example to drive that point home. Let's give one example. It says, if S is equals to M, G raised power X, T raised power Y, and this is equation of uniformly accelerating motion, they ask us to find the value of X and Y. So what I'm going to do there, this is displacement. Displacement is distance. Distance is length. Length is L. So I find dimension for this. I have L. What of dimension for this is mass. Dimension for mass is M. This is acceleration due to gravity. So I'm going to be having LT minus 2 all raised power X. Then this is time. T, dimension for time is T raised power Y. I hope we are seeing what I'm doing. I want to get the value of X and Y. Then I have L here. This is M. Do you know that this X belongs to both of them? So I have L raised power X. Then T raised power minus 2X. So that I have T raised power Y. Okay, what I'm going to do now is to collect like terms. I have L here. I have M. How many L do I have? 1. LX. Then I have T. I'm going to add this. So I have minus 2X plus Y. Okay. Now, if you watch now what we have here, MLT. So what I'm going to do there, I'm going to be taking the exponents in the right-hand side and in the left-hand side. So I take for L. For L, I will ask myself, do I have L in this side? Yes. What is the exponent? That is what is the power. So L here, the power is 1. L here, the power is X. Therefore, the value of X is equals to 1. Now, the next person I'm going to be looking at is M. Is there M here? No. For M now. Let me do for M. Is there M here? No. That means the power is 0. Is there M here? Yes, the power is. We don't have any coefficient for M here, so there's no need working for M. So let's go directly to T. Is there T here? That's for T. Is there T here? No. Is there T here? Yes. What is the power? Minus 2X plus Y. But I know X now is 1. So I have 0 equals to minus 2 into 1 plus Y. 2 times 1 is minus 2 plus Y. Then I push. I have 2 equals to Y. Therefore, Y is equals to 2. Now, my X is equals to 1, while my Y is equals to 2. So I've got the value of X and Y. I've got the values of X and Y. So if you want to complete it, you come to the equation and say S equals to M, G, value of X is 1, then T, value of Y is 2. So you can see that if M is a constant, and the constant is always R, so you have S equals to half GT squared. This is the equation we're talking about. Because in this question, M is constant. M is constant, so I omitted saying it in the beginning. That's why it is not carrying any exponent. M is constant. That is why I observed here. So if M is constant, I can bring in the value of the constant as half, since it is a uniformly accelerating motion equation. So we have S equals to half GT squared. This is how this equation was formed. How do I know that it's going to be 2 here? By looking for the value of Y. So that is all. Now we go back to our question. Question number 1. Remember, we are still in question number 1 all this while. We go back to our question number 1. It says we should find dimensions for this physical quantity. 1, it says surface tension. They say dimension of question number 1, it says the dimension of the following derived quantities are correct except, let's see, surface tension. Surface tension, you have to know definition. Surface tension is let me use S dot T, is force per length. So this is MLT minus 2 over length is in meter. So we still have M. I think so. Remember that length has its dimension as capital L, time as capital T, and mass as capital M. So force is MLT. Force per unit length is surface tension. So force is MLT minus 2. While length is measured in meter, its dimension is L. Its dimension is L. So this will cancel out this, leaving us with MT minus 2. So let's check. Is that correct? MT minus 2. Surface tension is correct there. The next one is density. Density is mass over volume. Dimension for mass is capital M, while dimension for volume is L cube. So we have M L raised by minus 3 dimension for density. Is that correct there? M L raised by minus, that is minus 2. So you see that this one is wrong. This one is wrong from the question. Then the number 3 is a force. We know that dimension for force, this one was correct from the question. Force is MA, which is MLT minus 2. We have done that. So is it correct there? MLT minus 2 correct. It's also correct in the question there. Then the next one is momentum. Momentum, that is MdV, which is mass, capital M, LT minus 1. This is dimension for momentum. Is it correct? MLT, is that, I don't know if that is minus 1. So this is dimension for momentum. So let's see the options 1 and 2. Any of the options that contains 2, because this is 1, this is 2, this is 3, and this is 4. Any option that contains 2 is wrong because dimension for number 2 is wrong. So you can see that option A will be wrong, option C will be wrong, option B will also be wrong because option A, B, C contains 2 and 2 is wrong there. So they are all wrong. The correct option will now be 3 and 4. Thank you. We move forward. Number 2 question says, fundamental quantities can be defined based on the following except, okay, we know what fundamental quantities can be defined by all of the following except number 1. It says they are units whose nature is indiscriminately known. No, that's wrong. Number I says they are the basis for measuring other physical quantities. Yes, they are the basis for measuring other physical quantities. We saw that in dimension. Number 3, they said they can be expressed as arithmetic combination of quantities. Yes, they can be expressed as arithmetic combination of other quantities. Number I is also correct. IV, they form a process of comparison between quantities. That is wrong. So option B is correct in number 2. Okay, question number 3 here says A cross B is equals to minus B cross A. A cross B is equals to minus B cross A. And the question is asking us, is A cross B equals to minus B cross A is one of the law of vector products, which implies that, okay, before we move ahead with this question, I would like to teach us about vector products. You know, when we come to vector, we say vector is a physical quantity that has both magnitude and direction. And the scalar is the one that has only magnitude and has no direction. Okay. We can add vectors. Vectors can be added, vectors can be subtracted. Also, vectors can be multiplied. Okay. Now, when we come to vector multiplication, we have two types of vector multiplication. We have dot product and we have cross product. We have dot product. When you say if vector A, let A and B be vectors. If I have A dot B, that is dot product. Dot products are, this is a dot product. Dot products are also called scalar products. Now, why are dot products called scalar products? It is because when you multiply two vectors using dot, this is because when you multiply two vectors using dot products, the final answer will be a scalar quantity. Remember, when we say scalar quantity, we mean it's going to have magnitude and no direction. Let me show us an example. If I have 2i plus j minus 6k, this vector A, and let vector B be 6i minus 3j plus k. So if I do A dot B, that is, I want to multiply both of them using dot product. I want to show you what we mean by the final answer will be a scalar answer. That is having magnitude and no direction. Now, before that, you observe that 2, this is 2. 2 in the direction of I. There is 1 here in the direction of j. And this is minus 6 in the direction of k. So the direction we have here is I, j, k. That's what we call the direction. 2 is the magnitude here. 1 is plus 1 is a magnitude here. Minus 6 is a magnitude here. 6 is a magnitude here in the I direction. Now, also observe that, or remember that I is also referred to as x direction. J is also referred to as y direction. And k is also referred to as z direction. So x, y, z, or I, j, k. So minus 6k means minus 6 along the z direction, or minus 6 along the k direction, whichever this thing you are using. So if I have A dot B, it's going to give me, I'm going to be having 2i plus j minus 6k dot 6i minus 3i plus k. So I'm going to be doing 2 times 6 is 12. I dot I is 1. Remember that I dot I is equals to j dot j is equals to k dot k, and they all equals to 1. Please don't come and say I dot I is I squared, just the way we've learned in complex numbers. Okay, so 2 times 6 is 12. I dot I is 1 plus, okay, 1 times minus 3 is minus 3. J dot j is 1. Minus 6 dot 1 is minus 6. K dot k is 1. So I'm having 12 minus 3 minus 6. So if I do 12 minus 3 minus 6, will give me 3. So my final answer is 3. If you observe this, my final answer, it's having only magnitude, no direction, nothing like I, j, or k. Having only magnitude, no direction. So that's why we say that dot product are also referred to as scalar product, because when we take dot product of two vectors, the final answer we are going to have is a constant, or you call it a scalar quantity. Remember, a scalar quantity is a quantity that has only magnitude and no direction. Okay. Then, what of the next product? We call it cross product. Cross product. We have what we call cross product. Cross product is like this. Let A and B be vectors. We have A cross B. This is cross product. This is cross product. Now, one thing you must know about cross product is that they are also called, this is cross product. They are also called vector product. Why are they called vector product? Because when you multiply two vectors using cross product, the final answer you're going to get will also be a vector. That's why we call them vector products. Now, cross product is done using determinant. Cross product is done using determinant. Okay, I'm going to show us one very simple example on cross product. Let's say that vector A is 3 minus 3i plus 5j minus k, and B is equals to I minus 2j plus 6k. Okay, if they now ask me to do A cross B, it's going to be I have I, J, K. I fill in A first. We have 3 here, we have 5 here, and we have minus 1 here. Then I fill in B. I have 1 here, I have minus 2 here, and I have 6 here. I use the method of determinant. So what I'm going to do here is that I will cover this one and work with this one. So we have plus, minus, plus as my convention. So I will have this times this. I will have 5 times 6 minus 2 times minus 1, all into this times this minus this times this. This times this minus this times this, because what I covered was I. Then minus, I open another bracket, or let me put this here, I, so that I can put minus j here. Okay, if I want to do for minus j, I follow the same way. I close the j, and that's why I'm putting minus j here. Okay, 3 times 6, that is 3.6 minus 1 times minus 1, 1 times minus 1, and that becomes for minus j. Then the next thing I will do is to open up the minus j and close up k. And when I close up k, I have plus k. Open a bracket for that. 3 times 2, that's 3 dot minus 2 minus 1 times 5, 1.5. And in that case, I'll be having 5 times 6 is 30. This is 30 minus 2 times minus 1 will give me plus 2. Do you get that? This minus this times this will give me plus 2. Then I have minus j into 3 times 6 is 18 minus 1. Then plus k. 3 times 2 is 6. That's minus 6 minus 1 times 5. Yes, that is for k. 1 times 5 is 5. Okay. So we have 30 minus 2 here, which is going to give us 28. 28 times I, we have 28i. This is plus 18 plus 1 will give us 19. 19 times minus j will give me minus 19j. And minus 6 minus 5 will give me minus 11. Minus 6 minus 5 will give me minus 11. Minus 11 times k will give me minus 11k. And this becomes my final answer. If you observe, when we do A cross B, our final answer has both magnitude and direction. Magnitude and direction. Magnitude and direction. That is why we call it a vector product. So vector product is cross product, and scalar product is the final answer for a scalar product is also scalar. So we should call the dot product. I believe this simple example is well understood. Now, finally on this note, I'd like us to know that A cross B is not the same as B cross A. So when they ask you to do A cross B, don't go and mix it up saying you are doing B cross A. However, A cross B is the same thing as minus B cross A. Did you get it? Okay. Also, in the same frame, A dot B is the same thing as B dot A. If they say you should do A dot B and you do B dot A, it will get the same thing. So this type of relationship is what we call commutative. This is what we call commutative law. What is really commutative law? When the order of multiplication or the order of selection in an algebra does not really matter, it is called commutative. Example, if I say 2 plus 3 will give me 2 plus 3 will give me 5. If I also say 3 plus 2, it will also give me 5. This is commutative. But this is not equals to this, rather minus this times this. So this one does not obey the law of commutative. If you observe that, it does not obey the law of commutative. Rather, this is what we call associative law. So these are the few things this question wants us to know. Okay, so we go back to our question. That is question number 3. It says, question number 3 says A cross B is equals to minus B cross A is not one of the laws of vector product, which implies that distributive law do not hold. Distributive law holds now for cross product. Commutative law for cross product do not hold. Yes, cross product don't obey commutative law. I think we have seen that. So we move to question number 4. It says a 200 kg truck moving at 24 meters per second is stopped in 16 seconds by the action of a brake. What is the average force applied by the brake? Okay. Let's take our parameters like I used to tell us. It says a 2000 kg block, M, is equals to 2000. And it now says moving at 24 meters per second. That means its initial velocity, or let's say its velocity is 20. Why would not call it initial? Because they did not say it starts from rest, or they just say moving. So let's call it, we'll see if it is either initial or final. 24 meters per second. Okay. It stopped in 16 seconds. They gave us time, 16 seconds. And by the action of a brake, what is the average force applied? They're asking us for force. What is the average force applied by the brake? Now, I've told us time without numbers that when you are given a physics question and calculation, the first thing you are going to do is to write out the parameters. When you have got all the parameters for that question, within the parameters, you will be able to find a formula that match all the parameters together, both the one that is given and the one you are looking for. Now, if you come here, I have M, I have V, I have T, I have F. I should know that Ft is equals to Mv, which I know is going to be Ft is equals to Mv. You remember this formula? And I'm looking for F, so F becomes Mv over T. By the time you use this formula, you are going to be able to deal with that question. So we move on to question number 5. It says specific heat capacity of a substance is 73 joule per kilogram per Kelvin. This means that, remember I would say specific heat capacity of a substance is that amount of heat that is able to raise a unit mass of that substance by 1 Kelvin. To raise a unit mass of that substance by 1 Kelvin. So what we are, if the material needs like 5 joules to raise a unit mass of it by 1 Kelvin, then 5 joules becomes its specific heat capacity. Now, this question is trying to say that the specific heat capacity of a substance is 73 joules per kilogram per Kelvin. That means it needs 73 joules per kilogram per Kelvin to raise a unit mass of it by 1 Kelvin. So with this information, I believe you can find your answer in the options. We move to question number 6. It says a tangential force of 50 Newton. I'm taking my parameters again. A tangential force of 50 Newton, I have F, 50 Newton. It says apply to a solid surface area of 6,500 centimeters square. Area 6,500 centimeters squared. Okay. And cause deformation. And cause deformation through an angle of, they gave me theta, angle of 0.02 degree. Okay. Then I say calculate the shear modulus. I'm looking for shear modulus, G, or which is called modulus of rigidity. Remember, we have done this in part 1 and 2. And this is how you calculate for modulus of rigidity. Okay. We go to question number 7. It said, in winter, aquatic organisms can survive at the bottom of the sea. This is possible due to, now let me tell you something about winter and what happens in the sea. Now, you know that the sea is an open area. Though during winter, in the Western world, for those of us that have not gotten there, we just came back from there the other day. So let me tell you what I observed there. During winter, there is always snow. There is always falling of snow. Now, when you go to the water bodies, you see that the whole sea will be filled with ice, will be covered with ice. You can, those of you that have watched the movie called Titanic, you know that it was the ice that was covering the sea that the boat actually collided with and caused that sinking. So that means in winter period, the sea is covered with ice. Now, if you observe something, if the sea is covered with ice, that means inside the water should be very, very cold. But that is not the case. What happened is that when temperature begins to drop during the winter, once it gets to 4 degrees centigrade, mark this, once temperature of the environment within the sea gets to 4 degrees centigrade, what happened is that ice begins to form on the surface of the water. Ice begins to form on the surface of the water. And when this ice begins to form on the surface of the water, what nature does with that is that it locks the surface of the water from excess cold entering more into the water. So at this point now, once there is ice at the surface of the water, the top of the water becomes very, very cold, whereas beneath the water, that is beneath the ice or deep ocean, becomes warm. This warmth is meant to keep aquatic life inside that water alive, because if the whole of the water freezes just the way the top is freezed, aquatic organisms down the water there will die. So what nature does is, once the temperature drops below, or once it gets to 4 degrees centigrade, the nature will build a very strong ice on the surface of the water. The thicker the ice, the warmer the down beneath of the ocean. And this is done to keep aquatic organisms alive. The ability of water to form ice at 4 degrees centigrade is called anomalous expansion of water. Water begins to expand uncontrollably. Anomalous, uncontrolled, not measured. So it's called at 4 degrees centigrade, water begins to expand. And that expansion is called anomalous expansion. So we go back to the question. It says, in winter, aquatic organisms can survive at the bottom of the sea. This phenomenon is due to, you can see anomalous expansion in option D. Can see anomalous expansion in option D. Okay, we'll go to number 8. It says, calculate the work done in lifting 300 grams of block through a height of this. Okay, work done. Let's write down our parameters again. It says, calculate the work done in lifting 3,000 grams. M is 3,000 grams. Remember, you convert to kilogram by saying 1,000 grams is equals to 1 kilogram. Then 3,000 grams will give me X. So my X becomes 3,000 over 1,000. And that will give me 3 kg. Okay. It says, calculate the work done in lifting 3,000 grams of block through a height through a height is equals to 0.2 kilometer, 0.2 kilometer, through a height of 0.2 kilometer. They say we should take G to be 10 meter per second square. Now, we are looking for work done. Work done, we don't know. Remember, I've told us in part 1 and also in part 2 of this class that work done is equals to force times distance and also times the angle of displacement. But when this cos, whatever the angle is, becomes 1, this becomes, that is when maximum work is done, we have F times distance. So we can say that work done is the force times the perpendicular distance. Work done is force times perpendicular distance. Now, but if you observe these options now, we don't have F with all those things here. So do you know that also that work done, F is MA, hope you know, F is MA, then times distance. Now, this formula is for linear motion, something occurring along the x-axis. What of if this work is done along the y-axis against gravity? You will now see that work done will now become mass, acceleration. Acceleration for gravity is G. Hope you know. This becomes G. Then, when we talk about work done along the y-axis, distance becomes height. Distance becomes height. And this forms the work done, the formula for work done along the y-axis. Why this one is formula for work done along the x-axis. So this is x-axis, and this is y-axis. Do you get that? So I'm going to be using this one here. So work done is M, G, H. I have my M, I have my G, and I have my H. So with that, you can get your final answer. Okay, that is question number 8. Now look at question number 9. It says, for rigid bodies, the radius of gyration is defined as, okay, in this case, we are going to define radius of gyration. Radius of gyration, K, is defined as the radial distance to a point which will have the same moment of inertia as the body's actual distribution of mass. Okay, so what we pick here is that radius of gyration is defined as a radial distance. It's a radial distance, and this a distance to a point, radial distance to a point. How do we calculate this radial distance? It must radial distance to a point which will have a moment of inertia which will be the same as the body's actual distribution of mass. Now, the relationship between radius of gyration and moment of inertia is given as I is equals to mk squared, or I is equals to mr squared k. Now, I is moment of inertia, yk is radius of gyration. So that is why we say that a radius of gyration is defined as the radial distance to a point which will have a moment of inertia. They must be equal. Which radial distance to a point which will have a moment of inertia which will be the same as the body's actual distribution of mass. As the body actual distribution of, so we have this, this, and this, or you have this. This is radial distance. This is radial distance. This is radial distance. Okay, so we go to our question and see what our examiner has for us. It says, for rigid body, question number 9. For rigid body, the radius of gyration is defined as 1. Radius of motion against its axis. Radius of motion against its axis. No, we never read about anything axis here. Number 2, gyration motion of distance body. No. Option C, radius of rigid body. Radius of rigid body. No. Option D, effective distance of the particle of a body from its axis of rotation. Correct. Option D tallies with what we have said here. We move to question number 10. A car starts from rest. Okay, now we start to bring down our parameters again, just the way I've taught us. A car starts from rest, meaning that u is equals to 0 meter per second. A car starts from rest with an acceleration of 0.2 meter per second, acceleration a 0.2 meter per second square. Okay, what again? We say find the velocity when it has moved a distance of 50. As you find the velocity, which I don't, when it have moved a distance, let me use s equals to 50 meter. Now, for this question now, a car start from rest. I have u, I have a, I have v, and I have s. Okay, this must be for uniformly accelerating motion. I have, remember we have s is equals to u t plus half. Okay, no, we should have something that will contain this. We have v squared equals to u squared plus 2as. Do you remember this? So we have u here, v is present, a is present, and s is present. This is the formula we are going to use. So the set find v. V will now be equals to u squared plus 2as all root. By the time you can put in the values 0 here, you put in the value a here, and you put in the value of s here, you are going to get the velocity of that stuff. Okay, that is question number 10. Question number 11 says the area of the curve under the velocity time graph is a measure of, okay, let me show you something. Velocity time graph. Velocity time graph. Let us take a motion of a car traveling in a velocity time graph. We have velocity, we have time. Now, I believe you have seen something like this. This is the motion of a car traveling and finally came to rest. Now, in secondary school, this was done very, very well. Now, if I want to get the total distance traveled by this car, that is, it traveled here to here. I want to get the total distance traveled by this car. I can get it by getting the area of this shape. That is, this one is triangle. Then I'll get area of a triangle. I'll get the area of this triangle. I'll get the area of this rectangle. I'll get the area of this rectangle. And I'll get the area of this triangle. But I say area of this plus area of this plus area of this will give me the total distance traveled. So that is one good information we can get from velocity time graph. So let's go back to the question. It says the area of the curve, the area of the curve, the area of the curve under the velocity time graph is a measure of distance traveled. So option B tells us that distance traveled. Let's go to question number 12. The vector product of two vectors that is parallel is always equals to 0. When two vectors are parallel to themselves, their vector product is 0. The next question here is question number 13. It says a hood bar of iron weighing 200 grams is heated to this temperature steam and is quickly transferred. A hot bar of iron weighing 200 grams is heated to the temperature of steam and is quickly transferred into 500 grams of water. A copper calorimeter of mass 50 kg. If the specific heat capacity of the iron, the calorimeter, and the water are that respect, they say we should calculate the final temperature. Okay, I'm going to solve this clearly for us for better understanding. Question number 13. It says a hot bar of iron weighing 200 grams is heated to steam temperature and is quickly transferred into 500 grams of water. A copper calorimeter of mass 50 kg, 500 grams of water in a copper calorimeter of mass 50 kg. If the specific heat capacity of the iron, that of the calorimeter, and that of the water are, for the iron is 33,336, for the calorimeter is 400 and for the water is 4,200 respectively. Calculate the final temperature. Now, looking at the board, heat gain by this ball is equals to heat loss by the ball. That we say MC theta. So MC theta is equals to MC theta. So, but now we have mass of the solid times specific capacity of the solid, then the temperature, and you have mass of the water times specific capacity of the water plus mass of calorimeter times specific heat capacity of calorimeter, then times the temperature change. In this case now, your mass of solid is given to you as 200, your mass of water is given to you as 500, your mass of calorimeter is given to you as 550. So you convert them to kilogram. Having converted them to kilogram, we have that the specific heat capacity of the calorimeter is this, is given. Specific heat capacity of the water is this, is given. Specific heat capacity of the solid, which is the ball, is given. Okay. We have that the test temperature was 20 degrees centigrade. You add your 273 to convert the degree centigrade to Kelvin. We are looking for the temperature 2, but the temperature 3, you say it was at steam temperature. It was heated to steam temperature. So you see, you convert this. Steam temperature is 100 degrees centigrade. Then plus 273 will become 373 Kelvin. Now, having all these parameters, if you impute them into this equation and make this theta 2 subject of the formula, definitely you are going to get a value called 40 degrees centigrade. That's what you are going to get, 40 degrees centigrade. So if you look at our option, that is option A. I want you to try this yourself. I've taken you this far so that you can do some work. And what you need to help me master here is how to coin out their parameters and this now. How to work out this. Theta 3 minus theta 2. Theta 3 minus theta 2. Theta 2 minus theta 1. Then you have mass heat gain by solid is equal to heat gain by the solid. So master this equation. Then please try and put these parameters into this equation and get me the value of theta 2. What you'll be getting there is 40 degrees centigrade. I believe that is clear. We move to question number 14. It says the following are correct about unit vector except, okay, we are going to be find what is a unit vector. That's the first thing we are going to ask ourselves. What is a unit vector? I will define. A unit vector is a vector whose magnitude is unity or whose magnitude is 1. So if you take the magnitude of a vector and the final answer you get there is 1, that vector is called a unit vector. Okay, how do you calculate for a unit vector? Let's say that A is a vector. Let's say vector A. If I want to find the unit vector of vector A, it's going to be the vector over its modulus. So the unit vector of vector A is the vector over its modulus. These are the two information you need to know about unit vector. One is that a unit vector is that vector whose magnitude is unity. And secondly, that the unit vector is even at the vector over its magnitude. Remember that if vector A is AI plus BJ, that is A in the I direction and this, then the magnitude of A will be root of A squared plus B squared. This is how you get the magnitude of A. The magnitude of A. So I think these are the information we need to know. So if you check that option, you will now see that they say there, option A unit vector has a unit vector has unit magnitude. Yes, just 1. Then option B is my own paper here. Option B is not that correct. It's not that visible. Option C says that A equals to, you see, option C is saying the same thing. So option C is correct too. Then option D say all of the above. I don't know if to choose all of the above because I didn't really see what my option B here is saying. So, but all you need here is the information that a unit vector is a vector which magnitude is unity, or you can say its magnitude is 1. And then to calculate for a unit vector, the vector over its magnitude the magnitude is calculated as this, if this is the vector. We move to another option, another question. Question number 15. It says a hoot is sounded at regular interval in front of a wall high and at a distance of 2640 meters. Okay. A hoot is sounded at regular interval in front of a wall high and at a distance of x is equals to 2640 meters, okay, from the wall. If the echo from the wall is heard simultaneously with the next hoot, how many hoots are made every 480 seconds? 480 seconds. They say take speed of sound in air to be, they gave me V to be 330 meter per second. Now, I would like to bring it to our notice that this is the first time echo is coming out in our exam. Since 2010, I've been solving this past question. So, and echo is not even in your textbooks. Okay, so I don't know why it is in the exam. Maybe they want us to start studying sound waves now. There is wave in your question paper, but it's not that of echo. Okay, but then, should it repeat itself, you should know that when we are calculating for echo, we use this formula, 2x is equals to Vt. X is the distance. And you see something about echo. Echo, if I make a sound, the sound will move. It hits a wall and comes back. So the total distance traveled by this my sound is, it will travel the distance between myself and the wall and come back. So it will become distance between myself and the wall times 2. For me to hear it, the sound wave must travel there, hit the wall and come back. So that's why we have total distance traveled will be 2x. 2x, 1, 2, 2x. Then is equals to the velocity of the wave times the time. Now, this question says that the distance traveled is this. And they say, how many hoots will we get in 480 seconds? First of all, we are going to ask how many hoots we are going to get in 1 second first. If you know in 1 second how many hoots you are going to get, then you can now know how many you will get in 480 seconds. So having gotten this parameter that x is equals to this, t is equals to this, v is equals to this, the first thing we need to find out is that how many seconds does it take this my sound wave to travel and come back? If I know how many seconds it takes it to travel and come back, that means by the time it travels and come back, I will hear the first hoot. It travels again and come back, I will hear the second hoot. So I will first of all know time that it takes my sound wave to travel and come back. So I will make t squared of the formula first. So we have t is equals to 2x over v. Then 2 times this over this will give me 16 seconds. This thing means that it takes my sound wave 16 seconds to travel and come back. So every 16 seconds, I will receive my echo. Every 16 seconds, I will receive. That means when there is first 16 seconds, I have 1 hoot. When the 16 seconds doubles again, I have 2 hoots. Okay. Now, that's why I say, hence, it takes the sound wave 16 seconds to travel from front and back. Hence, how many hoots now will we hear in 480 seconds? I will now say that 1 hoot is heard in 16 seconds. Then how many hoots will be heard in 480 seconds? It's going to be 480 divided by 16. You are going to hear 33 hoots because it takes 16 seconds to go front and back. So if you have 16 in 480 seconds, you will have 33 hoots. I believe that is very clear. So let's see the options. If that is there, 30 hoots, 30 hoots, 30 hoots, 330. Okay, we have 16 seconds. Then we have 480 divided by 16. 480. So if you have 1 hoot equals to 16 seconds, how many hoots will give us 480 seconds? If you do that, 480 divided by 16 will give you 30 hoots. Let's go to the option and see if we have our 30 hoots there. So that is option B. That is 30 hoots. Question number 16. Impulse of force is equivalent to even if you have not been following up, but you should have known this. And if you look at our first and second part in this course, Physics 101, you know that impulse is equals to what? Momentum. So impulse is equals to m into v minus u. Impulse is equals to mv minus mu. So you see, whatever way, so impulse is mv minus mu. Ft is impulse, while this is momentum. Okay, you can find your answer from there. Question number 17, it says, which of the following statement is correct? It said, friction depends on the area of the surface in contact. No, friction does not depend on the area of the surface in contact. Rather, friction depends on the nature of the surface in contact. Option I, that is I, sorry, not one. Option I. Option I says, viscosity is the force that opposes the motion of one fluid over the other. Yes, viscosity opposes motion of fluids of one over the other. So that one is very correct. Option I, it says viscosity depends on the nature of the surface in contact. No, viscosity does not depend on the nature of the surface in contact. So option 3, let us be picking it so we know what we are saying. We said option A is that friction depends on the area. Sorry, option I, friction depends on the area of the surface in contact. No, so I is wrong. Viscosity is a force that opposes the motion of one layer of the fluid over the other. I is correct. I says viscosity depends on the nature of the surface in contact. No, I is wrong. Then IV says friction depends on the nature of the surface in contact. Very correct. IV. So if you watch now, the correct ones are II and IV. So you look for that in the option II and IV, which is option C. But then there is something I would like us to learn about this friction. There is something we call loss of friction, types of friction. I would like us to know it. Should we will know that we can be able to answer it. Okay, on the board we have loss of frictions. I want to give you some laws of friction. Number 1, friction is not dependent on the area of the surface in contact. 1, friction does not depend on the area of the surface in contact. Second law, friction opposes motion between the surface. Friction opposes motion between the surface. You know, we call frictional force is an opposing force. When you want to push something or you want to move, there is a force not allowing you to move. That force is called frictional force. Until the frictional force is overcome, you cannot move from one place to another. Okay. Law number 3. Frictional force depends on the nature of the surface in contact. I've said it before. Frictional force depends on the nature of the surface in contact. Then law number 4. Frictional force is dependent on the relation with frictional force is independent, sorry. Okay, I've said that. Frictional force is independent of the nature of the, no, we said is independent of the area. 1, it opposes motion between the surfaces. 2, it depends on the nature of the surface. 3, number 4, is not dependent on the relative velocity between the surface. Frictional force does not depend on the relative velocity between the surface. And finally, number 5, law number 5, frictional force is proportional to normal reaction. Frictional force is proportional to normal reaction. This can be seen in this equation if we write that frictional force is equals to UR, where this is normal reaction and this is frictional force. So this is coefficient of what? Statistics. This is coefficient of friction. Coefficient of friction. This coefficient of friction. So you see that frictional force is proportional to the normal reaction. So I've given you 5 laws of frictional force. So anything they ask you about frictional force, whether frictional force is this, it must fall within these laws. So try to document it down and study it. The next thing I want to teach us about frictional force is types of frictional force. Types of frictional force. We have two types of frictional force. The first one is static friction, while the second one is dynamic friction. Let us define static friction. This is friction before motion. Static friction is the friction before motion. When a body is at rest, the friction acting on that body is static friction. Then when the body begins to move, there is still friction. That is why when the body is moving, it will finally still come to rest if nothing is done. What brought it to rest is the friction that is still acting on it. So when the body is at rest, the friction acting on it is called the static friction. And when this body is on motion, the friction acting on it is also called. We move to question number 18 now. It said the velocity of sound in air at room temperature is 340 meters per second. Velocity of sound in air at room temperature. Well, let's write it down. Velocity is equals to velocity of sound in air 340 meters per second. Okay. At room the velocity of sound in air at room temperature is 340 meters per second at a frequency of 560 Hz. They gave me frequency to be 560 Hz. 560 Hz. Okay. What is the distance between the successive crests? Distance between successive crests is written like this. What do we mean by successive crest? If we have something like this, this is a crest and this is a crest. This is crest 1 and this is crest 2. The distance between this crest is called lambda and is measured in meters. Do you get that? And this is another question that boils on echo or sound wave. Okay, so remember that for this, we have a formula we called V is equals to F lambda. Mark this formula. Just as you have marked 2x is equals to Vt for echo. Also mark V is equals to F lambda. So we are looking for lambda. We have lambda is equals to V over F. So if you use this, your F is given, your V is given, your F is given, and you are going to get your lambda. It's measured in meter. So that becomes a solution for question number 18. Move to question number 19. If we look at question number 19, it says the work done during a process of an isothermal change is, first of all, we ask ourselves, what are isothermal changes? Let's write that down. A process in which the temperature of the working substance, the substance here is gas. So a process in which the working temperature of the gas remains constant during the expansion or compression is called isothermal process. A process in which the temperature of the working gas remains constant, when the temperature remains constant during expansion or compression, that process is called isothermal process. We can also say that it is a process of constant temperature. So isothermal process is a process of constant temperature. Okay. So, but this thing happens in gas. Either the gas is expanding or is compressing. If the temperature remains constant, that process is called an isothermal process. Now, let's see something. The quantity, the Q equals to the W. So, and where W for gas is P the V. P the V. So this is an isothermal equation that this is equals to this. Work done, if the temperature remains constant, then work done is equals to quantity of heat. Then work done is also P the V. So this is what we call for isothermal processes. This is the equation that stands for it. So let's look at our options and see. Okay, this tallies with option D. This tallies with option D. So mark that for isothermal process. This can be seen under thermodynamics in your textbook. Okay, question number 20. Calculate the mass of the earth where G is equals to 9.5. Calculate the mass of the earth where G is equals to 9.8 meters per second squared. And they say that R is 6,400 kilometer, and they say that G is 6.7 times 10 raised power minus 11, and they asked me to calculate for the mass of the Earth. Mass of the Earth. I should calculate for mass of the Earth. To calculate for the mass of the Earth, I'm going to be using this formula that G is equals to Gm over R squared, where G is gravitational constant, which is given to me. M is the mass of the Earth, which I'm looking for. Then R is the radius, which is given to me. So I'm going to make M subject of the formula. I have G times R squared over capital G. And with this formula, I can get the mass of the Earth. So please master this. And from here, you can get this. So the mass of the Earth is calculated as this. The mass of the Earth is calculated as this. Okay, we move to the next year. So if you calculate that, you will see that your answer will be there. All you need to know is this. We move to the next question. Question number 21. It says the mode of heat transfer that does not need any material medium for its transmission is heat transfer that does not need any material medium for its transmission. Let's look at types of heat transfer. Let's look at types of heat transfer. Okay, I said let's look at heat transfers. We have conduction. When we come to movement of heat from one place to another, we have one, conduction. We have conduction. Two, we have convention. And three, we have radiation. So let's get their definition one by one. Okay, conduction. This is the mode of transmission of heat in which heat travels from hot part of the body to cold part of the body without any actual motion of the heated particle. In this one, heat will travel from hot part of the body to cold part of the body without any motion of the heated particle. Example, when you have a spoon that is a good conductor, like a iron spoon, and you use it to turn a hot soup, you see that soon the spoon gets heated up. The heat moves from the soup to the spoon. The heat did not actually, the soup did not actually move into the spoon, but the heat moved into the spoon. So that's what I say. It is a mode of transmission of heat in which heat travels from hot part of the body to cold part of the body without any actual motion of the heated particles. Now, the heated particles in the soup did not actually move into the spoon, but it was the heat that moved into the spoon. Okay, let's look at the next one, convention. Convention. It says, this is a process of transmission of heat from one part of the medium to another part of the medium by bodily motion of the heated particle. In this case now, the heated particle move from one medium to the other. The heated particle will do what? We move. Things that really undergo convention are mostly liquids and gas. Liquid and gas are the ones that actually are found in this aspect. And this is where we have ocean currents and ocean wave, land and sea breeze. When the day the land is heated up, at night the hot air from the land moves into the sea, and the cold air from the sea moves into the land. These are conventional motion of gases and liquids. So only liquid can do convention. Okay, in this case, the heated particle moves actually. The heated particle actually moves. Unlike in the first case, the heated particle do not move. Okay. The last one is radiation. It says this is the only process of heat transfer that can travel through a vacuum Radiation is traveling, moving of heat through a vacuum. Here, hence, it is defined as the process by which heat is transmitted from one body to another, without heating the intervening medium. Now, heat is moving from one body to another, but the intervening medium is not heated. Remember, we said that this is the only process of heat transfer that can travel through a medium, through a vacuum. Now, heat is traveling through a vacuum. We have heat, we have body A, we have body B, and there is a vacuum. Then heat will travel from body A to body B without heating this intervening medium. This medium is not heated. Yet heat passes through here and come to heat up body B. Are you getting what I'm trying to say? So in this type of heat movement, we call it what? Radiation. Where you see this one in the sun, radiation of the sun, heat coming from the sun to the earth. The sun, it passes through a vacuum without, it hits the earth, even without hitting the intervening medium. So that one is called radiation. So having known these definitions, let us now go to our question and see which option is appropriate. Okay, it says, okay, question number 21, it says the mode of transfer that does not need any material medium for transmission. It does not need any material medium for transmission. Mode of let's go back to question number 20. It says the mode of heat transfer that does not need any material medium for its transmission. The answer is radiation is the only one that does not need a material medium because it travels through a vacuum. It travels through a vacuum. And radiation is II. So option A is correct. Radiation is II. Option A is correct. Let's go to question number 22. Find the maximum speed of a particle moving with simple harmonic motion of that. Okay, question number 20. Okay, we have moved to question number 22. Find the maximum speed of a particle moving in simple harmonic motion. Remember, in our part 1 and part 2, we have talked about speed in a simple harmonic motion. We said that V maximum, it occurs when displacement from the equilibrium, when displacement is equals to 0. That is, we have that is equals to this root of a squared minus x squared. So when this one is 0, we have plus or minus w, which will give us a squared minus 0 squared. This minus 0 will still give me plus or minus w, a squared. Remember, this square can cancel here. So we have that V maximum is equal to plus or minus W A. Okay? So if that becomes the formula for V maximum, then this question is saying, question number 20 says, the maximum speed of a particle moving with simple harmonic motion is of period. Okay, they give me period. P is pi over 4. They give me period. P is seconds. And amplitude. They gave me amplitude. A is 25 centimeter. I think I need to convert my amplitude to meter. I will convert it to meter by having 25 divided by 100, which will give me 0.1 to 0.25 meters. Okay, so I'm applying this formula. That means my V maximum should be given as W A. A is given. I'm looking for W, but W is 2 pi F. So I need F. F is 1 over T. Do I have T? Yes, this is a period also written as T. So my F becomes 1 over pi over 4, which is written as 4 over pi. So if I've got my F to be 4 over pi, then I can now calculate my V maximum. Okay, we have moved to question number 22. Find the maximum speed of a particle moving in simple harmonic motion. Remember, in our part 1 and part 2, we have talked about speed in a simple harmonic motion, we say that V maximum, it occurs when displacement from the equilibrium problem, when displacement is equals to 0. That is, we have that is equals to this root of a squared minus x squared. So when this one is 0, we have plus or minus w, which will give us a squared minus 0 squared. This minus 0 will still give me plus or minus w, a squared. Remember, this square can cancel here. So we have that V maximum is equals to plus or minus W A. Okay? So if that becomes the formula for V maximum, then this question is saying, question number 20 says, the maximum speed of a particle moving with simple harmonic motion is of period. Okay, they give me period. P is pi over 4. They give me period. P is seconds. And amplitude. They give me amplitude. A is 25 centimeter. I think I need to convert my amplitude to meter. I will convert it to meter by having 25 divided by 100, which will give me 0.1 to 0.25 meters. Okay, so I'm applying this formula. That means my V maximum should be given as W A. A is given. I'm looking for W, but W is 2 pi F. So I need F. F is 1 over T. Do I have T? Yes, this is a period also written as T. So my F becomes 1 over pi over 4, which is written as 4 over pi. So if I've got my F to be 4 over pi, then I can now calculate my V maximum. Now, in calculation now, I have W, which is 2 times pi times F. My F is this. So 2 times pi times F times A, which is this. If you do that, you have the whole of this over this. 4 can cancel 4. So you're leaving us 2 pi over pi, because 2 pi times 1 is 2 pi. Then we have pi here. Pi cancels pi, leaving us with 2 meters per second. So that is a maximum speed, or you call it maximum velocity. And that option is option C. We go to question number 23. A process in which volume of a working substance, which is the gas, remains constant during an expansion or compression is called process which the volume of the gas. Now this one is, remember that we have seen a process which the temperature remains constant. We say that one is isothermal. So because of this, we need to define some terms in thermodynamics so that you can know that. We have defined isothermal as a process of constant temperature. Okay, I want to define isobaric. Let me call this one isobaric. Isobaric process. I'm also going to define isothermal, which we have already said before, process. I'm also going to define isochoric process. All this is for us to have them at hand. Okay. Isobaric process is a process of constant pressure. Isobaric process is a process of constant pressure. This can be proved from first law of thermodynamics. Isobaric process is a process of constant pressure. It can be proved from thermodynamics first law. Then for isobaric process, W is equals to P dV. For isobaric process, a process of constant pressure. Then we go to isothermal. We say that one is a process of constant temperature. A process of constant temperature. That one, we say that that the Q is equals to the W, which is equals to P the V. This is for isothermal process. Then the next thing is isochoric process. This is a process where the energy of the system is constant. A process where the energy of the system is constant. Okay, that is one. It is also a process where the volume of a system is constant. You see, for this guy, energy can be constant, volume can be constant. A process where the energy of the system is constant is isochloric. Also, a process where the volume of the system is constant is also called isochloric. It is also referred to as a system of constant volume. Isochloric system is also referred to as a system of constant volume. Okay, having known this, we can now go back to our question to see what they want us to pick there. So that is question number 23. A process which the volume of the working substance gas remains constant during expansion or compression is called isochloric. It's a process of constant volume. Isochloric is a process of constant volume. We move away from there. We move to question number 24. It said an object of mass 4 kg is acted upon by two horizontal forces. I think we have done this in part 2, 2022, 2021, 2022. Please check that up, part 2. Read that question, you will see it in part 2 or part 1, whichever one. Question number 25 says the amount of heat required to convert unit mass of a substance from solid to liquid at its melting point without any rise in temperature is called large. Question number 24. If you read that question, you observe that we've done that in part 1 of this our class. Question number 25. The amount of heat required to convert, that is latent heat of fusion. I've explained that in the other part of this class. Question number 26. Calculate the magnitude of gravitational force between two objects. Okay, magnitude of gravitational force between two objects. I believe that even from our secondary school knowledge of physics, we know that gravitational force is equals to G mm over r squared. So if you are calculating the magnitude of gravitational force, let's see what the question says. Calculate the magnitude of gravitational force between two objects of 90 kg and 120 kg. They're giving you two masses. The two masses. Then separated by a distance of 15 meters. This is the distance. The distance you are not, it's already in meters, so you are not converting. Then it now says take G, this G as 6.67 times 10 to the minus 11. So you can get your F. This is the formula that is needed to do that work. That is question number 26. We move to another question number 27. It said, which of the following is not a vector quantity? Okay. We know that velocity is a vector quantity, so I is correct. We know that momentum is a vector quantity, I is correct. We know that speed is a scalar quantity, is not correct. And we know that force is a vector quantity, is correct. And we know that mass, which is V, is not a vector quantity. So we have I, and I. Which option depicts that? You can check out that. The options we have, option A say I and I. I is velocity, I is momentum. Momentum, okay. B is anyone that contains I is not correct. So I is speed, is not correct. So option B is not correct. Anyone that contains V is also not correct. Option C is not correct. Then we have IV and V. IV and V. IV. Anyone that contains V is not correct. We've said that. So option C is not correct. Option D is not correct because they all contain V. And any other one that contains I is not correct. I. Option B contains I is also not correct. So the only correct option there is option A, I and I. They did not say only. Hope you know. It's not only I and I. It is I and I. That's why the examiner did not say I and I only. Because you know that there is another one that is missing from there. But this, since these two are there, they are the most appropriate answer. So we move to 28. He said if summation of fx in the x component is this and that of the y is that, and they are at right angle, calculate the resultant force. Now, this is also a question based on vector. Okay. Now, if we have the at right angle, mean that they are at 90 degrees to each other. Along the y-axis, summation along the y-axis is summation along the y-axis is 6.8 Newton, while along the x-axis is 5.7 Newton, 5.7 Newton. They asked me to find the resultant, which is R. Okay, I'm going to be using cosine rule here. You remember that says R squared is equals to x squared plus y squared plus 2xy cos theta. Now, if you observe, the theta here now is 90. The angle between them is the theta, is 90. Cos 90 is 0. The whole of this will go because 0 times the whole of this. So we are left with R squared equals to x squared plus y squared. So that R becomes root of x squared plus y squared. And if you do that, you are going to see your answer looking at you in one of the options. You have your x, you have your y. Okay. Question number 29. It says a force of 200 Newton acts on an angle of 120 degrees with respect to the positive x direction. It says calculate the component of this force in the y direction. Okay. This question also looks like the upper question. Let me explain something about it. It says a force of 200 Newton. We have F is 200 Newton. And it says act at an angle, the theta is act at an angle of 120 degrees with respect to the positive x direction. Okay, see something now. I will draw out this. He said the force is this and it's acting at an angle of 120 degrees with respect to the positive x direction. So I'll start from here and take one. You know, the whole of this is 90. Then 120 should be around here. Let's say this is 90. 120, 90, 100. Let's say 120 should be around here. So this is the force we are talking about. This is 200 Newton from here to. So if I'm to resolve this force, I'm going to be having summation of fx. Resolve it along the fx. You know it is f. Along the fx is f cos theta. When you are resolving along the fy, it is f sin theta. Hope you have this in mind. These are the components. Now, F here is 200 Newton, cos the angle covered now is 120 degrees. 120 degrees. The angle from here to here is 120 degrees. When you start from positive x-axis and you keep moving till you touch the vector, is the direction of the vector. Okay, this one is 200 Newton sine 120 degrees. So the direction of this vector is 120. Let us see what the option have for us. It says, ask at one respect to the calculate the component of the force in the y direction. So this is the force in the y direction. If we press sine 120, if we actually press sine 120 times 200, it will give us 173.21 approximately, or you say 0.20. That's option A. Question number 30. The loss of power as a signal passes along a wire is known as alternation. Option B is known as option B. Mark that and cram it. Question number 31 is a convert kilowatts hour to work performed in joule. Okay. Question number 30. Question number 30 is a convert 1 kilowatt hour to work performed in joule. I want to show us something there. Converting from kilowatt hour to joule, we have that 1 kilowatt hour is equals to 3.6 times 10 raised to the power 6 joule. Note this. 1 kilowatt hour is equals to 3.6 times 10 raised to the power 6 joule. Also note that, okay, converting from horsepower to watts, we have that 1 horsepower is equals to 746 watts, or it's equals to 3/4 kilowatts. Then I also teach us about power. Power. Power is the rate at which work is done. Okay, so power is equals to work over time, change in work over change in time. So we have seen that 1 horsepower is this in watts. Power is measured in watts, is measured in watts. Power is measured in watt or joule per seconds, or joule per seconds. Power is measured in watts or is measured in joule per second. There is something we call instantaneous power. There is something we call instantaneous power. There's something we call instantaneous power. Remember that work done is F dot D. Okay? And power is W over T. So if work done is F dot D over then T, do you agree to that? Okay. Do you know that? But, okay, let me clean up this. But V is equals to D over T, distance over time, or displacement over time. Therefore, power can be equal to, F dot V. Mark this. We have power to be equals to this, and power to be equals to this. So from this now, we now say that instantaneous power of a machine do not only depend on the force applied, but also on the instantaneous velocity. Instantaneous power of a machine does not only depend on the force, it also depends on the velocity. So you see that power can be calculated as force times velocity. Power can be calculated as work done over time. Okay, so I just proved this. Write down these parameters and study them very well. Okay, we move to another, that's question number 30. Question number 31, it says convert kilowatt. Okay, we have done that. Okay, question number 32, elastic limit is, we have done that in the subsequent class. Question number 33, 1 radian is equivalent to, remember that we have learned in our mathematics that 1 radian is equals to 180 over pi degree. Okay, you can put this like this. That is relationship between radian and degree. 1 radian is equals to 180 over pi degree, which is same thing as 57.3. How? If you do 180 divided by 180 divided by 3.142, you're going to get this. So 1 radian is equals to this in degree or this. So let's look at the option. 1 radian is equals to 1 revolution, no. 360 degree, no. 57.3. You see that? Yes. So option C is there. But there is something I want us to learn here before we move further. There is something I want us to learn before we move. Okay, first of all, I want us to observe this relationship between linear motion and rotational motion. Linear motion is a motion happening along the straight line, along an x-axis. Just normal, you're walking, you're traveling, you travel along the x-axis. But there are also motion that happens in a circle, like the tug. Hope you understand. Remember that we said that tug is rate of change of linear momentum over time. Now, this thing, remember we also said that linear momentum is just like, linear momentum is L. Why we have a linear momentum, okay, torque is rate of change of linear momentum. Now, sorry, let me bring that. If torque is equal to rate of change of linear momentum over time, this momentum is linear and it is momentum happening in a circle. Remember that we said that Ft is equals to mv. This is momentum also. This is impulse. Then F is equals to mv over t. Rate of change of momentum with time. This is a linear force. A force happening along the straight line. So it's mv over t. Then what of force happening in a circle is called torque. It is also momentum. This is momentum, angular momentum, sorry. Torque is the rate of change of angular momentum with time. Sorry. Torque is rate of change of angular momentum with time. What is torque? Torque is force in a circle, like you are opening a tap. You are applying force, but this force is not going in a straight line like X, but it's going in a circle. So that type of force going in a circle is what we call torque. Then it is equal to the rate of change of the angular momentum. Momentum in an angle, circular momentum, is represented as L. While momentum along the straight line is represented as P. P, that one will represent that one. So P is equals to mv. So we also know that F is equals to mv, so that F becomes mv over t. This one is a linear momentum. Why this one is an angular momentum? Remember, I want to remind us some things. Remember that we said that angular momentum is equals to mr. Angular momentum is equals to mr. Sorry, angular momentum is equals to rp. Okay, angular momentum is equals to rp. Angular momentum is momentum in a circle. If you want to convert it to linear momentum, you multiply by the radius, which is 2 pi. We are going to see that at the course of this study now. So this is converting, we are converting angular momentum into linear momentum. Okay, now that is why you can say that angular momentum is mvr. Do you remember that? It's equals to mvr. Now, we also said that ft is equals to mv. This is linear momentum, momentum along a straight line. Then F is equals to mv over t. So this, we now say force is the rate of change of linear momentum over time. Force along normal force, linear force, is rate of change of linear momentum with time. Then when force is happening in a circle, we call it torque. When force is happening in a circle, we call it torque. And we say that torque is the rate of change of angular momentum with what? Time. This is momentum, but this is linear, this is angular. And this is time, this is time. This is force in a circle, this is force along an x-axis. I believe this small understanding is vital and you understand what I'm trying to say. Now, you will now see that we have two types of motion that are very important. We have the linear motion and we have the circular motion. The circular motion that is making a circle is creating angles. It's creating angles. It's creating angles. That is why we call it angular. Why the linear one is linear on a straight line. So, relationship between linear motion and rotational motion. Okay, this part is the linear. Why this part is the rotational? Now, if you are talking about distance traveled, for linear, it's represented as s, or you call it x. Why for rotational, it's represented as theta, because it's an angle. Okay? For velocity, for linear, you see, you write it as v, and which is distance over displacement over time, or distance over time. Why this? V is written as w here, which is called angular velocity. Angular velocity, linear velocity, angular velocity. The x over the t. Here, our s is theta, so it's the theta over the t. Acceleration is represented as alpha here. Remember, acceleration is the v over the t. Here, acceleration is the w over the t, because v is, this w is represented v here. And it is second derivative. So acceleration is second derivative of this. If you differentiate displacement, you get velocity. This is velocity. When you differentiate velocity for the second time, you get acceleration. So if you differentiate velocity with respect to t, you get acceleration. This is distance traveled for a uniformly accelerating motion. If it is in linear form, we have s equals to initial distance ut, okay? But when you come here, you see that your s, which is displacement, is theta. Look at it here. Then initial displacement, this subscript 0 means initial displacement. We have ut. U is initial velocity. Remember that this is velocity. To make it initial, you put small o under it. So initial velocity times time plus half alpha acceleration, then t squared. Then look at this one, velocity. For uniformly accelerating motion, we have v equals to this. Remember this linear angular velocity. Then this is initial velocity. Then this is acceleration, while this is distance traveled. So these are relationship between linear and the rotational. So they ask you to calculate something happening in a circle or angular. You use this. If you talk about linear, you use this. I'm going to use one example to drive this point home, and I believe that will be very vital for us. Okay, let's look at this example. It says a flywheel is rotating. This is a circular motion at a rate of 35 revolutions per minute. Now, a motor speeds up the wheel so that when it is 32 seconds later, it is turning at the motor at 32 seconds, this motor is already turning at 85 revolutions per minute. Now, I should calculate the average angular acceleration, and I should leave my answer in rad per second. That means I will not leave my answer in revolution per minute. I'm going to leave my answer in radian per second. So solution. We have here that initial velocity at a rate of this is 35 revolutions per minute. That's the initial velocity. Now we are going to convert 35 revolutions per minute to radian per second. What do you do to that? You have 35 times 2 pi rad. Now for you to convert revolution to radian, you multiply by 2 pi radian. So 35 times 2 pi. Now to convert minutes to seconds, you also multiply by 1/60 seconds. Do you get that now? To convert 35 revolution to 35 radian, you multiply by 2 pi. Then to convert minute to seconds, you multiply by 1/60. So that will give me 3.7 rad per second. Please observe this. Again, we have the time. It's turning at this revolution per minute. That is final velocity at that time is 85 revolution per minute. We are going to convert this also to this. We have 85 times 2 pi rad times 1/60 seconds. And that will produce us 8.9 rad per second. Remember the question said we should calculate average angular acceleration. Average angular acceleration. Okay. Remember that angular acceleration is initial velocity, final velocity minus initial velocity. Let me call this initial. Let me remove this so that or I can call this. It's better like that. So this is the initial, this is the final. So average acceleration. Remember that A average is V2 minus V1 over T. So here is going to be WF minus WO over T, which will become 8.9 minus 3.7 over 32. Remember that they gave us in 32 seconds, and that will produce 0.16 radian per second. We have calculated the average acceleration. Okay, one thing you must note here is how we converted revolution per minute to radian per seconds. Okay, by multiplying, to convert from revolution to radian, you multiply by 2 pi radian. To convert minutes to seconds, multiply by 1/60. And that is what we did here. And we have that our acceleration, average acceleration in a circular motion, which is like if it is linear, you have v2 minus v1 over t. We have v2 minus v1 over t. And that is what we have gotten there. I believe this has a lot to teach us. Okay, so we move to question number 34. It says a sphere of radius 60 mm is dropped into a liquid of coefficient of viscosity. That it should be viscosity. They gave us coefficient of viscosity to be 8 there, or 0.8. When I say calculate the terminal velocity if the viscous force is this. Now, for terminal velocity, I think we have discussed that in the subsequent paper before this ones. We talked about viscosity force. We'll talk about terminal velocity according to that. We say that when a steel ball is dropped into a grease, it will keep traveling after a point, traveling with a constant velocity, which is called the terminal velocity. Please check up the other classes. Then number 35, it says hygrometer has a mass of 420 grams. A hygrometer has a mass of, we have m equals to 420 grams, and a uniform cross-sectional area of 7.5 times 10 raised to the minus 3 meters square. If it is placed in a liquid of density of the liquid is 1.35 times 10 raised to the power 3, then kilogram meter cube. Calculate the depth of the hygrometer. Calculate the depth the hygrometer will sink. Okay. If we are to calculate the depth hygrometer will sink, well, now this hygrometer is sinking in a fluid. Then the relationship between pressure and depth is that pressure is equals to rho gh. Okay, and this, they say hygrometer has a mass of this and uniform cross-sectional area of this. If the is placed in a liquid of density that, calculate the depth. We are looking at the depth. So we are looking for h. H is equals to pressure over H is equals to pressure over this. Do we have pressure? No. But do we have density? Yes. We have G is constant. G 10 meter per second squared. But you know that pressure is equals to force over area. Hope you know. Where force is mg over area. Hope you know. So we have 4,000. You first of all convert this 420 to kilogram, which we are going to be seeing that 1,000 gram is equals to 1 kilogram. So 420 gram will be equals to x. So my x becomes 420 divided by 1,000. And that will give me 0.42. That is 0.42 kilogram times 10 over the area 7.5 times 10 raised to the power minus 3. That will give me my pressure. Whatever you now get as pressure here, you put it here. Then you use your density to multiply your G so that it will give you whatever you are looking for. So that is that answers for question number 35. Question number 35. Okay. Okay. So we'll go to quiz. The quiz section, section B. First question says the surface tension on a soap bubble. I think we have dealt with soap bubble and bubble in a soap bubble and the other one in the first classes, in the former classes. When the word specific is used in thermal physics, is referred to as unit, a unit. unit mass. When the word specific is used, we are talking about unit mass. That's option C. Number 3, which of the following equation of linear motions is or are correct? Equations of linear motions. I believe we all know equations of linear motions. However, I just showed us relationship between linear motion and circular motion. Now, I want to write out the equations of linear motion so that peradventure you don't know it, you will write it down and master. Now, to drive question number 3 home, these are equations of linear motion along the x-axis. This is acceleration, average velocity also, displacement, average displacement, velocity again. When we talk about along the y-axis, we talk about free fall, falling along the y-axis. We have this plus or minus. Plus or minus, if it's going up, when you're going up against gravity, is negative. When you are coming down alongside gravity, is positive. So that is what we mean by plus or minus. So velocity, maximum height, velocity, maximum velocity, which is always 0 at the maximum height, then height. These are the formulas. So with this, you can look for your option in question number 3, the quiz side. Number 4 say, given two vectors, this and that, evaluate A dot B. I've done that for question number 1, A dot B. I think I've done that. Number 5 say, a wave is traveling from a positive axis to a negative axis as stated in the wave equation. Say, calculate the amplitude and the angular velocity frequency respectively. Now, for that question number 5, to solve wave questions, you use comparison. You know that for wave, y is equals to a sine wt plus phi. This is the first equation for wave. So we are going to be comparing this with the one they gave us. Here they say y is equals to 4 sine 3t plus 5x. Okay, so the question says we should find amplitude. A is amplitude, therefore A is equals to 4. Compare. Then the next one says we should find amplitude and the angular frequency. Look at angular frequency, that is W. Okay, we have that Wt is equals to 3t. T cancels T, therefore W is equals to 3. W is equals to 3. So that is what we are going to look for in the option there. And in the option there, we have 4 and 3 radian. Yeah, 4 and 3 rad. That settles that wave question. Number 6 say a mass of spring under simple harmonic motion. The maximum displacement from the equilibrium position is called maximum displacement from equilibrium position is always called amplitude. Maximum displacement from equilibrium position is always called amplitude. There is something I want to tell us about simple harmonic motion. Now, for simple harmonic motion, there are 2 features that characterize simple harmonic motion. For you to say that a motion is a motion, you look at a motion and say this motion is a simple harmonic motion, it must have these 2 characteristics or these 2 features. Number 1, the acceleration is directed towards the fixed point. The acceleration of the motion must be directed towards a fixed point. The acceleration must be directed towards a fixed point. What do I mean by towards a fixed point? You know that for me to perform this now, we have fixed, this thing is fixed. Then this thing moves up here and moves like this. The total displacement from here to here is what we call amplitude. That is the total point it can go before it comes back. There's always a restoring force. Once it goes, that's your total amplitude as you raise it, where you hold it before you leave it. That is the amplitude. And whenever it goes back, once you get to that point, it returns back. So that is the highest displacement, which is called the amplitude. So it is towards a fixed point. The acceleration must be towards a fixed point. That is 1. So you cannot look at a motion that its acceleration is not towards a fixed point and say it's a simple harmonic motion. Number two, the restoring force is directly proportional to the displacement from the equilibrium position. The restoring force, that is, once it goes here, the restoring force is directly proportional to the displacement. The restoring force is always directly proportional to the displacement from the equilibrium position. These are the two features of a simple harmonic motion. It must be directed to a fixed point, and the restoring force is directly proportional to its equilibrium position. Now, listen. Restoring force, like we have said before, that when there is a simple harmonic motion, there is always a restoring force bringing it back. A restoring force bringing it back, which makes it a free vibration. But if we use an external force to keep this motion going, that is what we call forced vibration. I think I've explained this thing the other day. So cram these two things, that the two features of a simple harmonic motion is that, one, the acceleration is directed towards a fixed point, one, and that the restoring force is directly proportional to the displacement from the equilibrium position. This is from here to here, is displacement from the equilibrium position. So we say the restoring force is directly proportional to the amplitude. Displacement from the equilibrium position is the amplitude. Maximum displacement, hope you understand. So the restoring force is directly proportional to the what? Amplitude, or total displacement, or displacement from the equilibrium position. I believe this is well understood. So we move to another question now. That question is question number 7. It says standard pressure is, we have done that before, converting pressure to Newton per meter square. We have done that. Number 8 says if the mass of the moon and its radius is this, and the rest, find the free fall acceleration. Okay, for you to find free fall acceleration is also acceleration due to gravity. Hope for that question number 8, it says if the mass of the moon and its radius is this, the mass of the moon and the radius is given as this, and the object on the, it says find the free fall acceleration, which is g. Find the free fall acceleration g of that object on or near the surface of the moon. So you're using this formula. Remember, they did not give us g. G is constant, so I brought it in here. So if you do this, having g as this, m as this, and r as this, if you multiply and divide, you are going to have 1.72, and that is option B, 1.71 or 1.72, because it's 1.7 for 714 or 715, and I approximated to 2 meters per second. Okay, that is for question number 8. That is for question number 8. Remember this formula. Remember this formula. It's also the formula we use to find the mass of the Earth. Then, okay. Now we move to question number 9. He said adhesive liquid. We have done that in the subsequent class. So go and read about adhesive liquid and cohesive liquid. Cohesive liquid and adhesive liquid. Number 10, a force of 20 Newton is applied at an angle of 40 above horizontal to a block that slides across the surface. How much work? Remember that work we have said is Fd cos theta. In this case, they gave us F as 20 Newton and they gave us theta as 40 degrees. Above a horizontal block that slide across the surface. How much work is done? Moving the block a distance d, they have given us 35 meters. So use this formula and you will get the work done there. Number 11, blood pressure is directly proportional to which of the following? Get to the subsequent classes. We have done that. These are repeated questions. We have done that. Number 12, which of the following is not true about mass of a substance? 1, it is scalar quantity. Yes, the mass is always scalar. It is weight that is vector. Number 2, its magnitude is constant. No, mass varies. Mass is constant. Yes. The magnitude of mass varies, but weight, magnitude of mass is constant. Sorry, the magnitude of mass is constant, but weight will always vary. Why? Because acceleration due to gravity always what? Varies. You see that on the Earth's surface, we have that g, is equal to 9.81. But we have calculated in the moon that G is equal to 1.72. You see it? So G varies, depends on where you are. And weight is equals to mg. So it depends on what G is to multiply the mass that will give you weight. Mass is constant, while weight does what? Vary. Depends on the location of the earth where you are. So that one is, say, its magnitude is constant, correct. Its unit is kilogram. Yes, the unit of mass is kilogram. So let's keep down the correct things. You say, which of the following is true about mass of a substance? It is a scalar quantity. Option A is correct. Its magnitude is constant. Yes, option B is correct. Its unit is kilogram. Option C is correct. Then it is measured with spring balance. No, the only thing that you can measure with spring balance is weight or tension or force. You cannot measure mass with spring balance. You can use every other balance apart spring balance. Spring balance is used to measure weight. So option D is wrong. Option D. Okay, the final question. 30 centimeter cube of a gas diffused in 2 minutes. What is the rate of diffusion? Use R equals to V over T. You have got your V in centimeter cube. Your V is in centimeter cube. Then you have your T in minutes. Ensure you convert your T to seconds. Then you are going to get your answer. I think that brings us to the end of 2022. Please try to take time to study. You see that the last year, which is 2022, was kind of different from the 2 years ago, meaning that the question system has changed. So please try to master this 2022 very, very well. There is something about it. Then try and master others, and then try to take down notes, okay? I believe by doing so, God will really help us in this exam. Don't forget to subscribe to this channel, like the videos, and ask your question in the comment section.